Hello and welcome to my presentation. My name is Naimot Oyewale and I will be talking about the naive Bayes algorithm. In the next few slides, I'll be talking about the naive Bayes algorithm itself, how naive Bayes algorithm works, the pros and cons of using naive Bayes algorithm, its applications, then building a naive Bayes model in Python, then conclusion. So what is naive Bayes algorithm? The naive Bayes algorithm is a classification technique that is based on Bayes' theorem in probability and has a strong independence assumption between the features or predictors. So the Bayes theorem of conditional probability allows us to calculate the posterior probability using this formula. So the probability of C given X will be equal to the probability of X given C multiplied by the probability of C divided by the probability of X, where the probability of C given X is the posterior probability of class or our target given the predictor X, and the probability of C is the prior probability of class, and the probability of X given C is the probability of predictor X given class, and the probability of X is the prior probability of predictor. Assuming we want to find the probability that Mike and his friends will play tennis today using the naive Bayes algorithm given the weather conditions. So we will be using these data sets to find the probability that Mike and his friends will play table tennis today. Looking at the previous data set, it has four features. So we have the outlook, the temperature, humidity, and windy. And we have two classes, which is yes or no. So we can name these features x1, x2, x3, x4, and the classes will be C1 and C2. Since the naive Bayes algorithm assumes that all features are independent of each other, we'll be using intersection to show the relationship between each of the features. So the probability of C1 given x1, x2, x3, and x4 will be the probability of x1 intersect x2 intersect x3 intersect x4 given C1 multiplied by the probability of C1 then divided by the probability of x1 intersect x2 intersect x3 intersect x4. So this equation can be further simplified into this, and so this can also be applied to C2. So substituting the equation in the previous slide, assuming today's weather is sunny, hot, the humidity is high, and it's windy, so the probability that the output is yes, given that it's sunny, it's hot, it's high, and it's windy, will be equals to the probability that it's sunny given that the output is yes multiplied by the probability that it's hot given that the output is yes multiplied by the probability that the humidity is high given that the output is yes multiplied by the probability that it's windy given that the output is yes, then multiplied by the probability that the output is yes divided by the probability that it's sunny multiplied by the probability that it's hot multiplied by the probability that the humidity is high, then multiplied by the probability that it's windy. So this can also be applied to this second class no. So substituting these values from this data sets into the previous equation, we are going to have the probability that the output is yes given these conditions to be the probability that the outlook is sunny given that the output is yes. So we can count the number of times that it's sunny here given that the output is yes. So this is 2/4. Then multiplied by the probability that the temperature is hot given that the output is yes. So this is 1/4. Then multiplied by the probability that the humidity is high given that the output is yes, so this is 2/4. Then multiplied by the probability that it's windy given that the output is yes, so this is 1/4. then multiply by the probability that the output is yes. So this is like 4 occurrence out of 7 occurrences. So we are going to have this value. Then here we are going to treat the divisor from the previous equation as constant because it is common to these two parties. So then computing this value, we are going to have 0.0134. So we are going to do the same for this class no, like counting the number of occurrence of no, which is like 3 out of 7 occurrences. Then looking counting the number of times that is sunny given that is no, the number of times that the temperature is hot given that the output is no, then the number of times that the humidity is high given that the output is no, then the number of times that it's windy given that the output is no. So computing this is going to give us 0.021. So a naive-Bayes classifier returns the highest probability, and so it's going to return the class no. So therefore, the probability that Mike and his friends will play tennis today is no. The pros and cons of naive Bayes algorithm. The pros: it is easy and fast to predict class of test dataset. When assumption of independence holds, a naive Bayes classifier performs better compared to other models like logistic regression, and less training data is needed. Then, it performs well in case of categorical input variables compared to numerical variables. The cons: if categorical variable has a category data which was not observed in training datasets, then the model will assign a zero probability and will be unable to make a prediction. Then, assumption of independent predictors, like we have to assume every time that the predictors are independent. We have three types of naive Bayes classifier. So we have the Gaussian, the multinomial, and the Bernoulli. The Gaussian is used when variables are continuous in nature. Then the multinomial is used when features represent the frequency. And the Bernoulli is used when features are binary. The naive Bayes algorithm can be used for real-time prediction and multi-class prediction, also text classification such as spam filtering and sentiment analysis, and also recommendation system. In the next few slides, I'm going to be demonstrating how to build a naive Bayes model in Python using the IMBD movie review dataset. So the first thing that I did here is to read in the dataset using pandas, then check what it consists of, then replace the sentiment with 1 and -1, 1 for positive sentiment and -1 for negative sentiment. Then view the most used words in the review column using the word cloud module, and then clean the data by removing HTML tags. Then remove special characters in the review column and also convert all the review column values to lowercase. Then convert all words to their stem words. Words like playing, played will be converted to play. Then remove stop words like they, is, using stop word module from Natural Language Toolkit. Here, I use two types of naive Bayes classifier, which are the multinomial and Bernoulli, to train my model after splitting the dataset into train and test using the train test split module. And these are the accuracies, precisions, and recall. Then I pass the test dataset and the predict dataset into the confusion matrix module. So this is the plot of the confusion matrix from the multinomial naive Bayes model prediction. This is the true negative, this is the true positive, then this is the false negative, and this is the false positive. So this shows that the model did so well in identifying the positive and the negative sentiments. Conclusion: the naive Bayes algorithms are often used in sentiment analysis, spam filtering, recommendation systems, and so on, And my explanations in the previous slides have shown that they are quick and easy to implement, but their biggest disadvantage is that the predictors will always be assumed to be independent. Thank you so much for listening.